algebra, we are kicking off the week with CO46, adding and subtracting polynomials. Like I said earlier, this kind of really falls in line with the elimination method. And so here are the steps. Step one, you are going to write each polynomial in standard form. Make sure each polynomial is written in standard form. That's why we talked about that in CO45. Make sure all the powers are greatest to least, okay? So we can kind of line up our like terms. Step two is you are going to align each polynomial vertically. Lining up like terms, and that's it. The way I said that, it sounds like there's more, but no. You want to align your polynomials vertically, and you want to line up the like terms, just like we did in elimination, right? We made sure the x's were above each other, the y's above each other, the constant above each other. The difference is we aren't trying to eliminate a term, so you don't have to multiply anything here. Okay, but we do want to make sure they're all lined up. And then step three, add or subtract each set of like terms. Add or subtract each set of like terms. Okay, so step one, write each polynomial in standard form. We've done that before. Step two, align each polynomial vertically, lining up like terms. We've had experience with that before with elimination. And step three, add or subtract each set of like terms. You've done that before too when you write something in standard form, right? You combine all the like terms, pay attention to the signs here. Now we're just doing it with more than one polynomial. Any questions on the steps before we go on? Finn? What's that?
You just keep it up.
Keep going?
No, keep it up.
Oh. How much longer do you need? Oh, your silence would be appreciated. Okay, all right, we're ready to roll. So, first example, here we go. It says add or subtract the polynomials, and the parentheses are used to separate them from one another. Notice I've got them written horizontally. That's because I want you to practice writing them vertically. So, are each of these polynomials in standard form? Yes. Okay. Our exponents in 3x squared plus 5x plus 9. We have our x squared term, then our single power of 1 term, and then our constant. Okay. The second polynomial goes right below it, lining up those groups of like terms. So 8x squared goes below 3x squared, 12x goes below 5x, and positive 1 goes below positive 9. Right? We are lining them vertically, matching those like terms up together. Just like if you were to add decimals, you want to make sure your place values are all lined up. You put the tenths below the tenths, the holes below the holes. Same idea here. Will?
At the end, do we have to write monomial, binomial?
No, you do not have to label these. Okay. Our operation that we're doing is adding them, right? So I'm going to put that in red here because it's not part of the polynomial itself. It's the operation. But now we just add them. 3x squared plus 8x squared is what? 11x squared. Why not 11x to the fourth?
It's only multiplication and division.
Because the operations of addition and subtraction do not change the powers. Okay? It's how many x squareds you have. You have 3, you get 8 more, total you have 11. 5x plus 12x is a positive 17x. And 9 plus 1 is a positive 10. You're done.
Really?
Yay!
Hooray!
This feels a whole lot easier now.
Yeah. I mean, it's just it's keeping track of all the terms. It's remembering that addition does not change the power. Some little things like that. But generally, this is math that you've done before. Okay. The next one, 70x minus 4 plus 9x plus 10. Again, are they in standard form already? Yes. X term, then a constant. So 17x minus 4. 9x plus 10. Line up your x terms, line up your constants. Again, we are adding here, so I'm going to put that in red. And you do need to pay attention to signs, just like you did with elimination, right? We have 17 x's, we're getting 9 more x's. How many x's do we have in all? 26 x's. We have a negative 4. We're adding positive 10. What does that come up to be?
6.
Positive 6. 26x plus 6 is our solution. Easy peasy, says Sam. Excellent. Questions on these first two? Okay. Next two, we changed the operations to subtraction here. 9x cubed plus 4, 15x cubed plus 3. Are they in standard form?
Yes.
Yes. 9x cubed plus 4, 15x cubed plus 3. This time we're subtracting, which does change things a little bit in the sense that, just like with elimination, you got to go back to that subtraction sign every single time, right? Rarely are there mistakes made in this first one because the subtraction sign is right there. You can see it. But 9x cubed minus 15x cubed is how many x cubes? Negative 6x cubes. Here's where the mistake happens, because if you're working too quickly, you think 4 plus 3 is 7. That's not what it's asking you to do. It's got to be positive 4 minus positive 3, which gives you a positive 1. You've got to go back to that subtraction sign every single time, just like you did with elimination, but it's worth repeating. Okay? So negative 6x cubed plus 1 is our answer here. The last one, 13x minus 10 minus 5x squared plus 2. Are they in standard form? Yes. But we have something a little bit different here that we haven't had yet. What's different about this fourth one compared to the first three? Oh, look at those hands. Fantastic. Paul. Right. In all the previous ones, we had the exact same groupings of like terms. X cubed, constant, constant. The same for up above there. This one, we've got this 13x and the 5x squared. Can we align those one on top of each other? No, because they cannot be combined. They're not like terms. So when you do this, the 13x minus 10, we don't have to worry about that one because it's got a power of 1 and then a constant. That's in order. But that 5x squared can't go beneath our 13x because they're not like terms. So we've got to put it out in front, create like a new column here for our x squareds. And that positive 2, what does that go underneath? The negative 10. Okay? We've got to line up those place values for the like terms, and because our first one doesn't have an x squared, and the second one doesn't have an x, we have to leave empty spaces. Here's what I recommend that you do in this situation. How many x squareds does our first expression have? 0. So I'm going to write this has 0 x squareds here. How many x's does our second expression have? None. So I'm going to write 0x there. Okay? And the reason why I'm going to do that, there's a reason why. I don't just do things just for the heck of it. It's because we're subtracting these. And the most common mistake that folks make, besides dropping their materials and hitting random buttons, is that when they subtract these, if they don't put that 0x squared there, they just bring the 5x squared down. But what are we actually doing here?
Subtracting.
We're actually subtracting 5x squared from 0x squared. Okay, our first expression has 0x squared. We're taking 5 away from that. 0 minus 5 is a negative 5x squared. if you write the 0x squared, you're more likely to catch that because you see 0 minus 5. If you don't put the 0x squared there, the temptation is to bring down your 5x squared and keep it positive, but it's not. We have nothing. We take something away from it. We're going negative. Okay, Finn.
So we have 0x2s, 1 and 0 x's.
Sure. Yeah. Our
How
next
many
step,
x's?
13x minus 0x is how many x's? Still 13. And still positive, because we started with positive, we took nothing away, we have exactly what we started with. This one does essentially drop down because it's different subtracting 0 from something than subtracting something from 0, right? We're starting with 0, take away 5, negative 5. We're starting with 13, take away 0, still have 13. And then negative 10 minus positive 2, negative 12. Negative 10 minus positive 2 is negative. If you put negative 8, then you added 2. Right? But minus positive 2, we're subtracting. We're going left. Maddie?
I had an analogy for the
Analogies. Love them.
I think it's
Analogies are like I can't think of an analogy. Go ahead, Maddie.
So it's like if you drop something light down onto something cement, it's not gonna fall through the cement. But if you drop something heavy through something very light, it's gonna go through the light.
Nice. I love it. Okay. Good. Questions on these? Okay. Your homework is the next page, which is pretty much more of the same, only expressions get a little bit longer. Okay. What do you want to do together? Pick one that you want to go over together.
The last one.
Of course, I should have predicted. The last, oh my goodness, I don't blame you. The last one here. Are these in standard form? No. Okay, we start with a squared term, then go to an x to the 5th term, then a constant. They're not in standard form. So when we write these, we got to make sure they are. Okay, our biggest power here is x to the 5th. So 15x to the 5th will be written first. We don't have any x to the 4ths in our first expression, but is there an x to the 4th term in the second one?
Yeah.
Yes. So we have to leave a space for it. If there wasn't an x to the 4th term in either of them, we wouldn't have to worry about it. But there is in the second one, so we're going to leave a space for it in our first one, 0x to the 4th. We have no x cubed term in our top expression. Do we have one in the second expression? Yes. So we have to leave a space for that as well. Okay. And we do have an x squared term. It's minus 18x squared. We do have an x term, minus 20x. And we do have a 3. We do have a constant, positive 3. So we've rewritten the expression in standard form. Look at our powers here, 5, 4, 3, 2, 1 constant. And we've left spaces for the terms that our second expression has, but our first one doesn't. The x to the 4th and the x cubed. Sam?
Where do you get 0x to the 4th?
How many x to the 4th does this one have?
None.
None. That's where it came from.
Okay, but like, what?
What's 0 times x to the 4th?
Nothing.
Nothing.
Oh, so
Right? So it doesn't change the value,
Oh.
adding it in there. But because I have a x to the 4th term in the second one that I have to combine with this, I have to leave a space for it.
that makes sense.
Okay? Adding 0 times anything doesn't change the value because it's just 0 anyway. Right? Our second expression, any x to the 5ths? No. So 0x to the 5th, going to leave a spot for that. We do an x to the 4th. We have 9 of them. We do an x cubed. We have negative 8 of them. We do have an x squared. We have positive 3 of them. We do have an x term, minus 20x. And we do a constant, positive 3. Okay? So both of them are now written in standard form. Powers, 5, 4, 3, 2, 1 constant. We've left spaces for the terms that one expression has, the other one doesn't. Those are in red there, right? And we've aligned them vertically, so now we can just go down through each column and add or subtract. We are subtracting here, so I'm going to do this in blue this time, because I do have that 0x to the 5th right out in front. I don't want to confuse the colors. But we start with 15x to the 5th, we subtract nothing. What do we still have? 15x to the 5th. We didn't take away anything. We have 0x to the 4th. We take away 9x to the 4th. How many x to the 4th do we have? Negative 9x to the 4th. The importance of writing that 0x to the 4th. It doesn't just drop down. We actually have to do the subtraction. 0 minus 9 is a negative 9. The next one, 0x cubes minus negative 8x cubes. Positive 8. 0 minus negative 8 is a positive 8x cubed. Right? You have to go back to that side, and it's negative. Subtracting a negative is a positive. Yes, sir?
For addition, do we have to put the 0?
For addition, it's less needed because stuff does just drop down. However, if you only do it sometimes, not every time, unless you really know what you're doing, there's the possibility to make a mistake. Not doing it. So I recommend doing it every time. But you'll find that with addition, you're right, terms do just drop down. But subtraction is different beast. Next one, negative 18x squared minus positive 3x squared. Negative 21x squared. Negative 18 minus 3 is a negative 21. Then, negative 20 minus negative 20. 0, they cancel out. And 3 minus 3, 0, they cancel out. Okay? So, 15x to the 5th minus 9x to the 4th plus 8x cubed minus 21x squared is our final solution. Questions, comments, concerns, complaints, compliments, congratulations, or criticisms on this? Okay, you have a generous minute to work on your homework. Your homework is the rest of this page.
Thank you.
We do review. We go back to greatest common factor and labeling polynomials a bit. But this is due for tomorrow. Make sure you show your work. Line things up vertically. I've given you plenty of space to show your work. Okay? Make sure you do that. All right. That's my math.
Don't forget to like and subscribe.